So in the previous video we have seen the generic cryptographic hash, and we have seen the working of compression box also. Now let us examine, let us learn more about the cryptographic hash here. So the above iterative construction is basically it's a cryptographic hash function, and the simplified version which is proposed by Merkle and Damgard. So he has proposed SHA1 as well as SHA2 also. So these two are the algorithm. SHA2 is the improved version of SHA1, and both is proposed by Merkle and Damgard. So let's look at the functioning of SHA1. So this diagram shows we have 80 words here, and each word length is 32-bit. It means total number of messages which can be given as input is 80 into 32, which will give you a multiple of 512 bits. Now if you look at the block size which is given as input, the maximum block size in SHA1 is 512 bit. So how to obtain this 512 bit is the word, we have to take the 16 word, and each word length is 32 bit. If you multiply 32 into 16, you are going to get 512 bits, which can be the input. Now let's say what kind of operation we are performing on each bit. So for this purpose we are using 6 shift registers here, which the size of 6 shift register is 160 bit, and we are going to perform some operation using this shift register. So if you look at the input which is given to the function is, we are giving here one word and a key, and we perform several operations on the bits which are present in the registers. So that operation is represented above here. You can see S1 we are shifting left shift by 5 bits, and S2, S3 and S4, which is the part of shift register bits. Again it is passed into function fi, which will do some work here, some calculation here we are going to analyze later. Then the key is provided, along with that the word is taken. So the word and the shift key value all are doing some kind of compression, and the outcome of this may be the hash code. Okay, if you look at the algorithm here, so first of all we have to initialize all the shift registers. So in the previous example also you have seen we are providing the initialization vector. So you can just consider this register like initialization vector only, which is being initialized by some bits, and this shift register will have all the values from we are just separating them into equal size block S1 to S5. Now let us consider how the block of this message is being processed, or how we get the hash code for each block. So originally your message is divided into chunks of multiple chunks of 512 bits, and each block will have message, then you have some padding bits, then the key size. These are the part of block. Okay, then the message in the sense your complete message will be given as input. Then padding character. So padding character, we'll examine. The padding is basically you will not get the, if you divide in message into equal size blocks, you will not get it properly. So to make it 512 bits, block we are just putting the padding character, and length field will just specify the length of your block. Okay, so this is the input. We create the 80 word array, and for each block we are doing some computational work here. You can look at this. The initial S1 is shifted 5 bit towards left side, and we are calling a special compression function, a special function fi, which do some operations on S2, S3 and S4. Similarly, we are getting key and the particular word as input. Then the result of S4 we are copying to S5, S3 we are copying into S4, in S2 we are shifting right side 2 bits, and the result we are storing in S3. S1 we are copying as it is to S2, and temporary variable, the result which you have computed above, we are copying into S1. So multiple operations are happening inside it, and we are getting, okay, at the end of this we are getting completely new value for your shift registers. Okay, so if you look at the computational work, it is varying depending upon your blocks. Yeah, your words here. Okay, the first 20, starting ranging from 1 to 20, the first 20 blocks we are performing f function like this, and 21 to 40 we are doing some other operation, which is XOR of S2, S3 and S4. I think you people are familiar with this symbol here. This is and we have OR operation. So we are doing bitwise AND, OR, XOR, negation, this kind of operations we are performing, and we are not doing we are not following the common operation on all the messages. So we are breaking into chunks, and each chunks are being performed differently. So anyway, this fi will be utilized in compression function here. So basically we'll put the result of this here. Okay, the same thing they are explaining here, like how SHA works. So basically your entire message is divided into 512 size block. It means each block will have 512 bits. Okay, so your length of message is expressed in 64-bit number, which is appended to the message. Between an end of the message, like based on the requirement, so we can have the padding bit which is inserted in between. So your message and padding character plus 64, that is the length of the message. Okay, so this all together will be multiple of 512 bits. So the padding character will start from 1, and you can have multiple zeros followed after that. Just they are the fillers, and the 16 words are initialized in the beginning. It means if you have 80 words, out of 80 words, the first 16. Okay, so each block is okay, these are the things which are doing inside a particular block here. So basically in each block you can have total 16 word, and like this you will get total 80 words together. So the remaining 64 bit can be obtained using this operation. You can just check it. It depends on some previous word, and you can do this kind of XOR operation to obtain a new word. So you can just examine, you can take any value between 16 to 80 and you can check this operation here. Okay, so if you look at the hash computation which is there in figure 7.6 here, they're talking about this figure. Okay, so they're using 160-bit shift registers which has some fixed predefined value, and yeah, then they are breaking into 532-bit words. If you multiply 5 into 32, you will get 160 bits. Then these bits are shifted based on requirement. We are performing some boolean operation like XOR and negation, rotate. These operations we are performing, we are shifting the bits which is inside the shift register to compute our compression function here. So that's all about SHA1. In next class we are going to learn about the MAC function and their performance. Thank you for listening.